Hello, my name is Emmanuel Chazard. I'm professor of health informatics and biostatistics in Lille. And this presentation interests on the expectations of French general practitioners about artificial intelligence modules, which can be clinical decision support systems or automated interpreters. The introduction first. The natural intelligence is a set of mental capacities for reasoning, for problem solving, and for learning. And the artificial intelligence, it's the ability of a process to respond to environmental stimuli or new data in a manner whose results are comparable to that of human beings. Several artificial intelligence modules exist, but their workflow today is never to replace the physician. They aim at assisting the physicians at double-checking tasks, saving time, reordering tasks, and so on, but never replacing the physicians. There are many applications today in ophthalmology, medical imaging, oncology, cardiology, psychiatry, or COVID-19, and so on. And in general practice, there are today already medical devices with automated interpreters, such as the intelligent stethoscopes that enables pulmonary or cardiac auscultation, or electrocardiographs with computerized interpreters. And 1/4 of French GPs were equipped with such devices in 2018. The development of artificial intelligence modules for physicians is today mostly technology-driven. First, researchers show that it's technically feasible to develop a device. Then there is a fundraising. And finally, once the device is developed, people try to find a new market. But this can lead to inconsistent projects. For example, we were asked to help to develop a device for automated interpretation of ultrasonographic images. But if a physician is sufficiently qualified to position the probe of the ultrasonographic device, then he no more needs an automated interpretation. Conversely, if a physician needs automated interpretation, then it means that he or she is not able to get the right image. So such a device, even if it works, is totally useless. What we expect is a development of modules that would be market-driven. So we first need to identify acceptability criteria for artificial intelligence modules. The objective of this work is to identify domain-independent criteria that would make a hypothetical artificial intelligence module desirable for general practitioners. Material and methods. Now, we designed a questionnaire, which is a paper-based questionnaire. We tested it with 8 general practitioners and iteratively improved it. The first part collects data about general information, the age, gender, type of practice, and so on. And it asks the physician which devices he or she currently uses. Of course, devices with automated interpreters. We did not use the term artificial intelligence because it's usually not clearly understood by the physicians. In the second part, we ask, imagine a hypothetical device with a diagnostic or therapeutic decision support module. Would the following features encourage you to purchase such a device or not? The first item is it saves me time, and for instance here I ticked the radio box. It would strongly encourage me. And the second item, it can be used by the patients in the waiting room, and here if this happens I would never buy it because I don't want, etc. So we have in total 33 items with 7 possible answers. We recruited the participants by random selection from a nationwide directory of general practitioners. We sent them a paper form with a paper cover letter and with a pre-stamped return envelope, and we systematically phoned them after 2 weeks to improve the response rate. We analyzed the data. The Likert scales were encoded from -3 to +3. Items were classified as incentive when their mean was between 0.7 and 3, deterrent when their mean was between -3 and -0.7, and neutral when the mean was between -0.7 and 0.7. We also performed statistical tests to compare the items means versus the age, the sex, and the rural or urban practice. Here are now the results of the survey. In the National Registry, we have about 120,000 general practitioners. We randomly selected 2,000 of them. We could find the complete address for 200 of them. And we sent 200 questionnaires. We get an answer rate of nearly 70%. 13 questionnaires had to be excluded due to the poor quality. And finally, we analyzed 126 questionnaires. You can see on the right the age pyramid. We had about 50% of women. The average age was about 48 years old. Men were a little older than women, as in the French GP population. 71% of GPs were in group practices. 71% of GPs were in urban practices, and GPs in urban practices were significantly younger than in other practices. 36% of GPs already used to use an electrocardiograph with computerized interpretation. The other devices with artificial intelligence were less frequent. We had 6% of GPs with a connected blood pressure monitor, 6% with an automatic or semi-automatic defibrillator, 2.4% with a connected saturometer, 2 physicians with a connected bathroom scale, 1 with a connected glucose meter, 1 with a connected thermometer, and no physician with a connected smart stethoscope or a dermatological pathology diagnostic device. Here are the 33 items with the 7 possible answers. So you have a dark blue when a feature makes the physician say that he or she would definitely buy the device, and dark red when he or she says, I would never buy this kind of device. And you can see on the top 19 items that are incentive with a lot of positive advice and very few negative advices. At the bottom, 4 items that are deterrent, and in the middle, 10 items that are neutral with a lot of it has no impact advices, and also with half I would have negative advices and positive advices. Here are the features that are classified as incentive, and they relate to artificial intelligence modules that would make or eliminate a urgent diagnosis. This is the most important point. It is for urgent diagnosis. Or modules that would make a diagnosis for which the GP is not competent or for which the specialists are not available. Physicians also would like modules that would register information in the electronic health record directly, or that would enable to share information with all other healthcare professionals. They also expect modules that would simplify procedures, save time, enable to spend more time with the patient, or delegate tasks to the secretary. They would expect modules that would predict a risk category and that would enable personalized medicine, that would enable to involve the patients and reassure him or her, but also modules that would enable to cut short patients' abusive requests, such as certificates or sick leaves, and so on. And finally, they would appreciate modules that would train the GP himself or herself. Here are the 4 deterrent features. So physicians say that they would never buy a module that automatically triggers an emergency call or that automatically decides without the GP intervention or that makes a diagnosis for which the GP is already competent or a device that could be used by the patient or his family in the waiting room without physician and without secretary. And here are some neutral features. So for the physicians, those features have no impact, no positive impact, no negative impact. They don't mind about them. So they say they don't mind about the reputation of their practice with patients, the high-tech image of the practice, the patient entertainment. They don't mind about the way the information has to be captured, the need for training, the use of personal smartphones. They don't mind about the economic model of the device, and they don't mind about the degradation ability of the device. There were some population-specific preferences. So young physicians enjoyed a lot of different items simply because they are probably more receptive to artificial intelligence modules, in generally speaking. But also men preferred modules that could automatically trigger emergency call, that would enable to cut short patient service requests and that would save time. Women relatively preferred, of course, modules that could decide automatically. And physicians in urban practice preferred modules that would simplify a known procedure or enable for personalized medicine. And this is interesting, only physicians in rural practice preferred modules that would exclusively use their personal smartphones, because as those physicians have to move a lot from a house to another, they want to carry as less as possible weight in their luggage. The discussion now. So we made a random draw and we get a high response rate of 70%. So we get some results that are probably representative of the French GP population. We could observe that the proportion of GPs owning an ECG with automated interpreter was 25% in 2018, and it's now 36%. We can give some recommendations for the developers of artificial intelligence modules. First, they should focus on real-life workflow, task delegation, and time saving. Secondly, they should focus on urgent diagnosis more than chronic conditions. Today, a lot of devices are developed for chronic conditions only. Third, they should never try to replace the physician. Fourth, they should adopt interoperability standards to enable data recording in the electronic health record and data sharing between professionals. They should also forget about reputation, entertainment, patient self-use, and so on. But what is interesting, they could also develop modules that help GPs deal with abusive claims. Interestingly, if you develop a module that does not work and that always answers no to the patient, sometimes it can be very useful in practice. And there are also some consequences for researchers in the field of artificial intelligence. Algorithms are not everything, so we need for usability evaluations. And there's also a need for a design process which would be driven not only by technology as today, but also by the user's needs. Thank you for your attention.